Okay, you're on.
All right, let's talk about matrices. So,
You may have to project your voice though.
oh, you mean
Unless you want a microphone extension. That's another reason.
Okay, very funny. Very funny. I can play that game.
So ghetto.
Okay, so I think you guys see where I'm going with this now. I'm just giving you the general formation of a matrix, right? I'm labeling the matrix as A, and then I'm labeling entries with subscripts, right? So, A subscript 1, comma 2, Joanna refers to?
First row, second column.
Right, it refers to the entry in the first row, the second column of matrix.
A.
So then, Joanna, what do you think about this entry? What would we call this?
A, 2, 1.
Yeah. Okay, and this one is going to be
A, 2, 2.
dot, 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 A2. And this would go dot, dot, dot down to A.
And
Instead of N, we can use another letter because if you use N, then you're implying that the matrix is square, right? So if we go with another letter, then we can allow it for that. So this will be M, correct? M, comma,
1.
right? This is going to be
A.
M, comma, 2, dot, 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 until eventually we get to A, M, comma.
N.
Okay. All right. So the information here goes row, which is horizontal information, comma, column.
And there's the last one on
Yeah, because this thing technically could go on. We don't want to limit the dimension, right? Okay. I guess one thing we could do is we could start with this simple arithmetic involved with matrices. So specifically addition, subtraction, multiplication of matrices by scalars. Is it reasonable to say that in order to be able to add two or more matrices, add or subtract two or more matrices, the dimensions of all of the matrices involved must be the same? Okay, if you have a matrix that is a 2 by, here's an example. Here's a 2 by 3 matrix. Okay, that means it's got 2
Row.
and
3.
okay. So here we go. I don't know. 1. What did I say? 2 rows, 3 columns. 1, negative 1, 0, 1, 3. Aha. Okay. Let's call this matrix A. Okay. And let's call this matrix B. Oh yeah, I should be clever that way. Okay, and then I could call this matrix C. Okay. So this one's a 2 by 3. This one is a, what is this one? 3 by, right. 3 rows, 2 columns, yeah? And this one is a 2 by 3, right? So, if I asked you some questions, for example, and I guess Arash, when we do this, when you get back from New Brunswick, you're going to set it up there so that they can see the text, right? Ideally, we do this from over there so that if you guys need to reference this, it's like you have notes.
Oh, okay.
Right?
You know what you can do
Yeah.
if you're not afraid of the radiation of the smartboard? You can record your screen on the smartboard.
I know. You know what? The more I think, I used it extensively last year, and I don't feel comfortable with it. The more I think about it,
Like,
I don't like the idea of sitting underneath that thing like every day for X, number of minutes.
I feel you.
So.
But if you need a scribe for 5 weeks, if you once.
Basically, you're on a yearly meal plan, basically. Okay. So, A plus B equals question mark. Solution.
can't add them because they're not the same dimensions.
Oh shit.
Agreed?
Or,
The dimensions of the matrices are the same. So for example, this would be A1, comma 3. Where's the corresponding entry in matrix B to add to A1, comma 3? Where's B1, comma 3? It doesn't exist. Okay, so the correct solution to that is no solution, and Kim is right. Somebody create a question for me over here, which, with addition and or subtraction, that would be reasonable. Put up your hand. Yes, Arash.
I can't see C that much, but I'm assuming A and C have the same thing. So A plus C will.
A plus C. By the way, I'll incorporate a multiplication of a scalar in there as well, because that's something you do as well. So let's say I asked you what A plus 2C was. What do you think the implication is there?
A,
I'm just trying to go by whoever's hand went up first. Yes, you want to.
A plus 2C, like.
So the 2C component would correspond
so
to,
basically, like A plus C.
correct, which is the same thing as multiplying each of the, your name? Kuzi. Multiplying each of the entries in C by, and then
Small.
adding that result to matrix A, right? So we could do that. Now, could you do this all in your head? Yes. I'll write it out for now, just because we're starting out. Yes?
What does it say for the first answer, no solution
Since dimension of A does not equal dimensions of B. Since is, this is since,
Yeah, I just didn't know what it
and this is therefore. Okay? Yeah.
What's the last? Sorry, what's A1, 3 and A2, 3 for C? So C to 1, 3 and C.
Oh, you're asking for the entries?
No, yeah, I can't see it. Yeah.
Oh, okay. So I'm going to give you the first row from left to right.
Yeah, okay.
4,
Yeah.
negative 1,
Yeah.
0. And then the next row,
Yeah.
2,
Mm-hmm.
1, 1.
Okay, thank you.
Yeah, this is getting tough for you guys to see at that angle, eh?
Yeah.
Especially you, because the angle's tighter. If you want, you can sit there
Yeah,
too.
it's fine.
Okay, so wherever, what the hell, where's A? So we have 1, negative 1, 0, 3, 1, a half, plus 2 times. Am I expecting you to write all this? Absolutely not. Can you do this in your head? Yes. I'm going to swing over here. Okay, so we'll just follow order of operations and all that. And again, I'm writing out all the steps now because it's the first time, so you guys will correct my arithmetic if there are any errors. 8, 4, negative 2, 2, 0, 2. So I've doubled all of the entries in matrix C, and I'm going to add all the corresponding entries. That's going to give me a 9, a 3, a negative 2. Please double check my work. A 1, and a 2.5. Did anybody get that? That's either bad for me, bad for you. 1 got that? Anybody else get that?
Yeah, that's right.
2? I need a third usually. Okay. Okay, good enough.
I didn't really have a chance to do the question.
Oh, we'll do it.
Yeah.
And of course this applies to subtraction, right? Addition, subtraction, the matrices have to be of the same dimension. Now, for multiplication,
Zoo.
Yeah. Nothing.
okay. The procedure of multiplication in a matrix follows the following recipe or algorithm, which I'm going to show you. And once you become familiar with that algorithm, then I'll show you how that particular algorithm or system of quote-unquote matrix multiplication has value by looking at a specific example. But what I can tell you is, in the case of multiplication, if I asked you how to multiply, if you could multiply matrix A by matrix C, the answer would be no solution. And then the question is, why? Well, I've got to show you what the algorithm is first, okay? And I will tell you that A and B can't be multiplied by each other. And I'll show you how you go ahead and do that. You literally just have to follow a recipe. And then we can make a general statement about what the dimensions have to be of, let's say, a couple of matrices if you need to multiply them. So let's look at A multiplied by B. So we'll literally just write down A. Can you quote me the first row of A followed by the second row of A?
First row is 1, 0, 1.
Next.
-1, 3.5.
Okay. And so that is a 2 by 3 matrix, correct? And could you please give me the entries for B?
First row, 1, -1.
Okay, 1, -1, yeah, the next one?
0, -4.
0, -4, yeah.
And then 3, 2.
Okay. So this one is a 3 by 2 matrix, correct? So the algorithm for multiplying matrices is as follows. Once you write them all down, then I'll go through the algorithm. Visually, you want to see this. I don't know if this might be useful for them to see, but whatever. When you bring back your thing tomorrow, we'll fatten you up with some lunch, and I'm not going to... The thing is, like, there's no carefully here. Carefully is going to involve breaking. So, anyhow, the first row / column entry of matrix A will be multiplied by yeah, but you're going to lose the angle on that. That's what it's, you can't.